My name is Brian Arnall with Oklahoma State University, and I'm the Precision Nutrient Management Extension Specialist. I approached producers and consultants from Oklahoma and Kansas to share their grid soil sample data with me. Over the years, bringing in that data, I've been able to get over 500 fields sent to me. We have about 30 counties represented in Oklahoma with soil samples. We also have 9 Kansas counties. One of the goals of this project was to look at how variable the soils of our region is, and then use this data that we're collecting to evaluate the economic viability of variable rate technologies, variable rate lime, phosphorus, potassium. With this data set, we're able to look at different crop markets, high, low markets, different input costs, and compare it over soils in different crop rotations. So we could look at a continuous wheat rotation versus a corn, soybean, wheat, or anything along those lines, and really get to dig in about where is the economics of variable rate nutrient management. As we bring them in, we're able to evaluate the variability of nutrients in any given field, so we can look at what is the average field pH. And so if we look at our sample deck, which is about 497 fields that have soil pH, the average pH is a 6. Now the range in any given field is a 1.8 units. That's significant. You start looking at it saying that each field has about a plus or minus 1 unit, so it'll go from a 5 to a 7. Also, if we looked at it, almost a third of our samples had a pH range of greater than 3 units, meaning the field average was still a 6, but an average field would go from a 4.5 to a 7.5. That means extremely acidic to quite calcareous, and that's going to impact how our roots grow. That's going to impact our phosphorus use and our potassium use. On our phosphorus levels, we look at an average level right at about 30 ppm Malic 3 and Bray P1. And that's a good average. That's right at sufficiency for most land grant recommendations. However, the average range was 60 ppm, meaning most fields would go from a single digit to well above sufficiency and into a point where we're trying to get to drawdown if you're using a maintenance versus drawdown level. And so the P levels are highly variable out in the field. Also, our K levels came back around 150 on the average field, which is right at or above optimum or sufficiency level. But the range was also equal to the average, about 150. Meaning we still, our NP and our K and our pH, all of our nutrients are highly variable across the field, showing the need for going beyond a composite soil sample into really more intensively sampling to better understand our variability and to better manage our nutrients for both economics and environmental sensitivities.